Hi again, this is Dave. Welcome back to my channel, Old Steam Powered Machine Shop. We just could not contain ourselves. We had to see if this would run on compressed air, and the big engine does run pretty good on compressed air. So now we're going to take a few things apart, clean some bearings, and check some things, and kind of explore the way it's built. And so we'll be checking it out here. The governor was stuck, the center shaft pin was stuck, and Tom spent some time one rainy day last week and took it apart and freed it up. So it's ready to go back together. Thanks a lot for the comments and all the likes and the subscriptions. I really appreciate it. We'll get right to it. This is some exploratory work just to see what it looks like in this big engine and see how it's made. So pulling the valve out of it, it's basically, we started out wanting to polish up this square slide to get the rust and old grease off of the slide where it runs against the davit here. So, taking the slide valve out, and everything has come pretty easy so far. These are some big brass nuts and lock nuts on each side of the valve for adjusting the lead. Take this packing out of here, yes, before I can pull that out. I don't want to burn a lot of time, so I'll do that and I'll be back. I decided to go a little different way. This pin is not threaded into this, but it's a very tight fit, and it's supposed to be. And rather than disturb it, I was able to turn it a little bit. I'm going to do it different. I'm going to take the lock nut off, brass lock nut off of here, and screw the valve rod out that way. And then I'll be able to take this square section piece right off. So let's see how this goes. I put this back on to keep it from turning. Nice to work on something that isn't all stuck up. And I gotta move these lock nuts back a little to give it some room. There it is. Okay. I'll take this off again. And that's what I was trying to do. Clean up these surfaces.
Gotta screw these lock nuts clear off the other end. That's what they look like. There's two of them. One's a lock nut. They go on each side of the slide valve to adjust the valve to center it up on the ports so that the lead is the same on both ends, theoretically. Okay. There's the valve rod. If you remember the valve rod that I made for the Frick a year or so ago on one of the videos, how badly it was worn, this is just as smooth as can be. That's the slide valve. See the machining marks on it. A little bit of corrosion on the bottom. Over here and take a look at the steam chest. The light's not very good in here, but no grooves, no wear marks, no nothing. Pretty much as machined. This was a little worse than I thought with the surface rust, and I'd like to polish this up really good. So I'm going to take this out after all. I'm going to press it out. I don't think it'll come out real hard. There it is, just a press fit. Got a part number stamped in it, that goes up. These are all the parts from the valve setup. I wanted to show this to you before we put it back together again. This is the valve rod. You got your really nicely made brass nuts with lock nuts, and of course somebody has to get on them with a chisel to tighten them up. But that's polished up and ready to go. This is the slide. Took it out, cleaned the rust off it, polished it up. And I'll press this back in, tighten the nut down. This is the packing gland, almost like the one on the Morris engine. There are two of these bearings that the slide valve rod slide goes in. They're Babbitt lined. They're in very nice shape, no scratches on wear. The slide valve is a pretty interesting design. I really like it. It's got a bridge here for the exhaust ports, and there's a bridge on the exhaust port, so it's actually got two intake ports and two exhaust ports. I'll show you that. This, I mean, it's in really nice shape. There's no wear marks or anything on it. These are the edges that uncover the port to time the admission of steam, and on a lot of them they aren't even machined. They're just rough cast. These are machined really nice, and it has quite a wide bearing face on the bottom where it slides back and forth on the bottom of the steam chest in a machine place there. Valve rod drops in here, and these need to be adjusted up so that there's just a little bit of play so it can kind of move around just a little bit, and then these tighten down. And of course it has to be adjusted left and right to get the lead the same on both the front end of the cylinder and the back end of the cylinder. That's okay, that's it. We'll be starting to put it back together again. Tom is over here getting all the studs squared away on the steam chest. We ended up replacing two, and of course it's my theory that bought-in hardware, nuts and bolts, were so bad back then that the engine manufacturers made their own in order to make them real close tolerance. And so when you start fitting old manufactured nuts with new manufactured studs, you find out the fit is not right. So we're having to deal with that with those studs on the steam chest. Also discovered that these studs here for the packing gland on the valve rod are not standard thread, and you need to watch out for this if you're messing around with old machinery, because you find this quite often. Anything that was built before 1900 or so, you're apt to find half-inch 12 instead of half-inch 13. So if you're trying to straighten out some threads with a wrong tap and die, you're going to have a problem. So we will commence to put this back together again and be back. I got everything put back together loosely here on the big engine, and before I put the cover back on it, I got to adjust the slide valve, and I thought I'd show you how to do that. Now this is not completely timing the engine, because I'm not going to disturb the eccentric at all. The eccentric is what determines the amount of lead the engine has, and all you're doing here is balancing that out between the two ends, centering it basically, so to speak. So the lead is really good, whatever it is,
because the engine ran really good on compressed air. What we have to do first is find top dead center. Well, I'll show you how to do that on the other side of the engine. Okay, in order to set the valve and even up the lap or the lead, we have to be able to know the exact top dead center and bottom dead center of the engine. And the way you do that, of course you can't see the piston in the cylinders here, so I've got it almost on top dead center, just kind of like by eye. And I put a mark about 1 inch down on the crosshead here. So I'm going to turn the engine back until those marks line up. I hope you can see that. Okay, so there we are, about 1 inch down the stroke. And I put a mark right here next to my pointer. Okay, now I'm going to turn the engine back past top dead center and to the mark again. And then I put another little mark here on the flywheel. So if we bisect these two lines, these two marks, and find the center point between them and bring it back down to our pointer, it will be top dead center, or pretty darn close. So you can just use dividers here and change it about half of the error. Okay, that comes right in the middle of the mark. So that right there is top dead center. And I'll put a mark right there. Top center. Okay, bottom dead center, same deal. All the way down. Come back about 1 inch. Of course, the further up you put your mark, the more accurate it will be, but the further apart your marks will be on the flywheel, and it gets kind of hard to measure between them. But this will be plenty. Okay. Mark there. Mark there. Oh, those are way wide. I don't think I can reach them. Actually, you could use center punch marks. I don't want to punch the flywheel all up. A little bit more. Nope, not too much.
That's it right there. Bottom center. Okay. Okay. Top center. I'll move over on the other side. Okay. So here we are at the slide valve. And that just glides across those ports. So we're at top dead center. This is the head end. We're at top dead center, and this port should just be cracking open with whatever amount of lead that we want to have. And we don't know what it is. We just want to make it the same on both sides. So that port should just be cracked open, and it's not. So I'm going to back these nuts off a little on this side until, I don't know if you can see it, but I can just get my knife blade in there. And that's what I'm going to go by. I'm just going to have a knife blade thickness of lead. That much at the top, a little more at the top, that much at the bottom. Alright, we're going to run these down till we don't quite tighten up. You want to let this have just a little bit of clearance to rattle around and self-align itself. Okay. Alright. So now I got to move the engine to the bottom dead center. So I'm moving it around to the bottom dead center mark. Bottom center. And if we did it right, we should have the same amount of port showing on this side. Let the oil off so you can maybe see a little better. And it's more, quite a bit more. Probably, we got 2 knife blades on this side. So we'll go back just a little bit. Tighten this one up. Move this one back. I think I went a little too much because that's about what we had before on the other side. I'll take it up just a little bit. Just a little bit more. When this is operating, the steam pushes that tight up against the port. Steam comes out of from underneath the governor. I explained that in video number 3.5. That's just a full knife blade. I don't know what that is, probably 30-second, something like that. Let's check it on the other end one more time. Top center.
Yep. I can just feel a little drag when I slide that knife blade in there. So the lead is equalized on both ends. Now how much the lead is depends on the way the eccentric is set, and I'm not going to disturb that because it ran really good under compressed air. I don't know, I'm not a real fan of lead, a lot of lead, especially in a real low speed engine. They start up better if you don't have much lead, but I think that'll be about right. So I'm going to tighten these down where we're at, and we'll put the steam chest cover back on. Tom did quite a little bit of work on these studs. We replaced 2 of them, and they happen to be standard course 5/8 threads right out of the Dorman catalog. The Napa guys downtown got them for me overnight, so that saved us having to make 2. Ran the die in on all of these. They appeared to be slightly stretched. Probably somebody at some time has just torqued the living snot out of it and distorted them a little bit, but we got them all pretty good now, and we got a new nut here for the one that was missing. This is the stuff I use around steam. It's called Tight Seal. I've had this can for a long time. This stuff never sets up, and you'll be able to take the gaskets down without losing them, and it seals really good. It's kind of like clay almost, maybe a little like Play-Doh, but you just smear it on there and it's amazing stuff. A lot of aircraft mechanics like it for valve covers and stuff, so you don't have to destroy the gaskets every time you take something apart to check something. There is a gasket on here, and it appears to be in good shape. It's not the original gasket, I'm sure, because I can see part numbers on the gasket material. Well, that's about it for this time. We're about ready to start running some pipes to the big engine and running the exhaust out under the floor. That should be fun. And we'll be finishing up the 18-inch pulley put up on the line shaft for the big engine to run. And we got some other smaller projects going on too next time. So thanks a lot for all the support and the comments and the likes and the subscriptions, and we'll talk to you next time.